A factory production line is a system for making things. It is a very organized way to produce many identical items quickly. You find these lines in factories all over the world. They build the cars we drive. They assemble the phones we use every day. They even package the food we eat for dinner. The core idea is simple but powerful. A large, complex job is broken down into many small, simple steps. Each step is performed in a specific order at a dedicated spot. A part or product moves from one spot to the next, growing more complete with each stop until it is finished. Imagine a very long table. This table represents the production line. On this table, a product is built. The backbone of any production line is the system that moves parts. In most factories, this is a conveyor. A conveyor is a mechanical apparatus that transports materials from one location to another. The most common type is a conveyor belt: fabric, rubber, metal. You might see a similar, smaller version at the checkout counter of a grocery store. In a factory, these belts can be hundreds of meters long. They move at a steady, controlled speed. This speed dictates the pace of the entire production process. It ensures a constant flow of work to each station. Along this moving path are the stations. A station is a designated area where a specific task is performed. At each station, a particular operation changes the product in some way: cutting, drilling, painting, applying a protective coating. Each station has the exact tools and materials needed, arranged for efficiency. The flow between these stations must be continuous and balanced. If one station is much slower than the others, it will create a bottleneck. Parts pile up before the slow station, while workers after it have nothing to do. Factory planners spend a lot of time online balancing. They time each task and distribute the work evenly among the stations. Buffers between stations, small areas that hold a few parts, help absorb minor variations in speed and keep the line running even if one station briefly stops. People and machines are positioned along this belt. Each person or machine has only one job to do. One worker might attach a single screw, the next station might weld, another inspects. Because each task is small and repetitive, it can be learned quickly and performed efficiently. This method completely changed how we make things. Before the modern production line, a single skilled craftsperson would build an entire product from start to finish. This person performed dozens of different tasks. It required great skill and a very long time. The final product was often expensive. The innovation of the assembly line, famously perfected by Henry Ford for his Model T car, was to divide the labor. By breaking the process into small, manageable pieces and moving the work to the worker, factories could produce goods on a scale never seen before. This shift made goods more accessible. It lowered the cost of making almost everything. More people could afford items once considered luxuries. The production line is a philosophy of efficiency and flow, an engine that powers modern industry. Understanding how it works reveals the structure of our modern economy. A modern production line is a blend of human skill and machine power. The workforce is composed of people and automated systems, each assigned to tasks they perform best. Robots are a common sight in today's factories. These are not walking, talking robots of science fiction. They are large, powerful robotic arms bolted to the floor. They excel at repetitive work, heavy lifting, and superhuman precision. A robot can lift a heavy car door and place it perfectly every time. Robots take the dirty, dangerous, and dull jobs, like welding and painting, often in enclosed booths to protect people. They repeat motions thousands of times with no variation, ensuring consistency, crucial for quality. However, people remain essential. Humans bring flexibility, problem-solving, and a sense of touch. They spot subtle defects and handle delicate tasks. Collaborative robotics lets people and cobots work safely side by side. To keep a complex production line running smoothly, it needs a nervous system, sensors. Sensors are small electronic devices that detect changes, the eyes and ears of the line. They detect presence, trigger machines, and time operations. They measure temperature, pressure, and position with incredible accuracy. They feed data to control systems, coordinating actions automatically with minimal intervention. Beyond running the line, sensors are vital for quality control, checks at every step, not just the end. A vision system compares each part to a perfect reference and flags deviations instantly. Defective parts are removed early, saving time and materials. Final checks are comprehensive. For phones, screen, speakers, cameras, connectivity. For cars, brakes, interior lights, and a long checklist of systems. This relentless focus on quality builds customer trust and strong brand reputation. Section 5. Real-world lines. Examples we all know. The most classic example is the automotive assembly line. A bare metal frame starts at one end, moving slowly and transforming into a complete vehicle. At a series of stations, the engine, transmission, body welds, interior, doors, and windows are fitted. Near the end, seats and wheels are installed, and a finished car rolls off the line. In food, washed potatoes are sliced, fried, seasoned, inspected, weighed, bagged, sealed, dated, and boxed, thousands per hour. In electronics, clean rooms host tiny robots placing chips, workers connect ribbon cables, and automated stations test functions. Clothing. Fabric is cut automatically, pieces move to stations where each operator sews a specific seam. Sleeves, collars, then the garment passes along until finished, enabling fast, affordable production. Those are some familiar examples. Across industries, the principles remain the same. In an environment with heavy, fast-moving machinery, safety is the highest priority. Machine guarding uses barriers, metal cages, fences, and clear shields around dangerous parts. These guards prevent workers from being pinched, cut, or crushed. Emergency stop systems, large red buttons and pull cords, let anyone cut power instantly in an accident or malfunction. Personal protective equipment is mandatory. Safety glasses or goggles, steel-toed boots, earplugs or earmuffs in noisy areas. Depending on the task, workers may need gloves, hard hats, or respirators. Safety is built into culture through training and procedures. For maintenance, lockout-tagout prevents re-energizing a machine by mistake. Safety is an integral part of the production process itself. Protecting people protects production. Despite careful planning, breakdowns happen. A single failed motor, a broken belt, or a malfunctioning sensor can halt a section. Stoppages ripple downstream. No output, but labor and power costs continue. Quality issues can cascade if not caught early. Late detection leads to scrap or rework, wasted time and materials. Monotony risks error. Good factories use job rotation, breaks, and engagement. Just-in-time runs lean, but delays can starve the line of a critical component. Lean manufacturing targets waste. Anything not adding customer value. Total productive maintenance emphasizes proactive care and shared responsibility. Jidoka builds intelligence into machines. Stop at problems, then fix at the source. Kaizen empowers teams for continuous improvement. Smarter robots, the Internet of Things, and AI make lines flexible, data-driven, and efficient, still the engine of industry.